50 newtons. Let us take another example. The wagon is pushed by a force 100 newton to the right, like the previous example. But this time, the wagon is also pushed by another force to the left with a strength of 40 newton. Then, the wagon is pushed by the following result force. 100 minus 40, since it's in the opposite direction, equal to 60 newtons. Again, the wagon is pushed by the combination of the two forces, which is equal to 60 newtons to the right. Let's finally take three forces on the wagon. 100 newtons to the right, that's one force. 150 newton also to the right, and 50 newtons to the left. Even though we have three forces, the wagon moves with, or starts moving or accelerating with one force, the combination one, which is 100 plus 150 minus 50 equals 200 newtons. So wagon moves by the combination force of 200 newtons to the right. Let's go to the third point, which is also very important to point out. The movement of an object like the wagon is coming from the forces that touch the wagon itself, or direct forces. The line could be quantified. It means we can calculate it with numbers. So when we say in point 1, all forces, we talk only about all forces touching the object. So in this picture, there are a lot of forces drawn with blue arrows. These forces don't matter because they don't touch the wagon directly. Only the forces drawn with red arrows are taken into account as forces on the wagon because they touch the wagon. Let us take another example on forces touching an object. This long truck has 4 parts: A, B, C, and D. Now, if the motor is in part A, then we all have a feeling that the force originates, for the lack of better word, from part A. Nevertheless, when dealing with, for example, part C or wagon C, it is only the force from B to the right and the force from D, wagon D, to the left that you take into account when calculating the acceleration on wagon C. This is very important because it is those two that wagon C is connected to and actually feels, not A, even though it originates from A. Finally, let us look at the wagon problem. Just a small side comment, I will neglect the person's own mass when I deal with this problem to make it easier, and it doesn't affect the core of the problem. So now let us look at the case when you push the wagon from outside first. You push the wagon with your hands, let us say by 100 newtons to the right. What happens in the same time is that your feet is pushing the ground with at least 100 newtons in the opposite direction, to the left. That's how you generate the force. You need to push the ground to the back. It is kind of like the source of the force that makes your hand push the wagon. I need more Newton laws to explain it in detail, but we don't need it. We just think about it. The feet are the source. We have to push it in the opposite direction in order for our hands to push the wagon to the right. To convince you, think of the ground being icy and slippery. Then your feet will glide back and you won't move the wagon at all. Now, since the feet touch the ground and not touch the wagon, it does not accelerate the wagon, even if it is the source. It doesn't touch it, it doesn't count. That is what we said. Therefore, only the hands touch the wagon. So the total force on the wagon is one force, and that is 100 newtons. Now we are approaching the end of our problem. Finally, we look at our problem when you are inside the wagon. Again, we see that your hands are pushing the wagon with 100 newton to the right. But here comes the important part. What do your feet push now? It is the wagon floor. So now your feet also touches the wagon and is pushing with 100 newtons to the left. Remember, the feet always pushes in the opposite direction. So since the force from the feet also touches the wagon, when you are inside the wagon or inside a box or inside a car, it must be taken into account for the total force on the wagon. So the total force on the wagon, the force that moves the wagon, is 100 newton to the right from your hands minus 100 newtons from your feet on the wagon floor to the left equals 0 newtons. So the total force on the wagon is actually 0. No change in movement. Because every time you push the wagon by a force using your hands, any size, say 1000 newton, in the same time, always in the same time, your feet will push the wagon to the back or in the opposite direction by the same size of force size. Like we used in this example, I said 1000 minus 1000 or the opposite direction. And the net effect will be always 0 and it will not move. Thank you very much for following me.